product.
Vector C.
Hmm?
C.
C, CC.
No,
It's a
C.
cross P. Yeah,
C.
so that would be a C vector. Yeah, that would be a C vector. But I'm asking that what would be numerically? What would be this A cross P? So how do we represent? What would be the magnitude of this cross vector cross product?
AB sine theta.
Yeah, AB sine theta. Right, Saad? Forgotten. So this is now you remember Saad, right?
Yeah.
And the direction would be this n hat, which is calculated by this Maxwell's right hand thumb rule, right? So this we needed, and then we talked about this torque. So torque is when the couple force are applied, right? Okay, I didn't talk about this torque. Yeah, I have talked about this torque. Mm, yeah, I have talked about this torque, right? So we have some couple forces, equal forces acting in the opposite side, right? So the torque is just the product of the force and okay, let me give. So yeah, so you guys understood about this torque, right? Yes, guys. We have this couple force, right? So this is acting in this way, right? So this will create some rotational force, and that is the torque, right? So this is the line of action, right? And torque is defined as the product of this distance between the line of action, let's say D, right, and the couple force. So this was the torque, right, guys? Okay,
Yes, sir.
yeah. And then we talked about this. So then we talked about this torque on electric dipole, right? So in external uniform electric field, so we have this electric field, right? We have this electric field, and some electric dipole is placed, right? So some electric dipole is placed. This is minus Q, and this is plus Q. So, Saad, do you remember what would be the direction of this dipole moment? Yes, Saad.
Uh,
Yeah, the direction of the dipole moment.
right. Right side, sir.
Right, right side.
Or plus.
So, okay, so we have this dipole, right? This is minus Q, this is plus Q. So what is the direction of the dipole moment? It goes from minus to positive, right? So this is the direction of the dipole moment. Right,
Yeah.
Saad. Am I correct, Aisha and Mariam? Am I correct?
Yes, sir.
Yeah. So in this case, the direction of the dipole moment would be this, right? And this
Yes.
P vector, yeah, this P vector is making an angle theta with this electric field. Okay, understood, guys?
Yes, sir.
Yeah. So now what would be the force that acts on this charge and the force that acts on this charge? So what would be the direction of force acting on this charge? Yes, Saad. What would be the direction of the force on this charge?
It would be right, sir.
Yes, now you are correct. Yeah, this is force which is in the direction of the electric field because this is positive charge, right? And Aisha, what would be the direction of the force for this charge?
Opposite to electric field.
Yes, correct. So opposite to the electric field, right? So this force is again equal. This is minus Q, right? So you guys can see that we have a couple, right? This force is acting in this direction and this force is acting in this direction. So let us draw the diagram here. We have a couple. This is force and this is the other force, right? And the angle is, this angle is theta, right? This angle is theta. So what is the line of action here, Mariam? There are two lines of action, right? So what are those? Yeah.
One in the opposite direction and one in the direction of electric field.
Yeah, so the line of action is the axis of this force, right? So this is one line of force, this is the other one. Right, Mariam?
Yes.
And the distance between the line of the force would be this one. Let's write it as R. So this distance is how much? This distance is, let's say, 2a, right? So this distance would be, we have to figure out. So let's say this is x. Okay. Understood, guys?
Yes, sir.
Yes, sir.
Yeah. So what would be the torque on this system, right? This will obviously create. So this is a dipole which is placed in some electric field, right? And one force is acting in this direction, and the other one is this direction. So this will experience a torque, right? Right, guys? So this will experience some torque in this direction, right, guys?
Yes, sir.
So the magnitude of torque would be this perpendicular distance x into the magnitude of this force, right? Right. So
Yes.
Yes.
yeah, so x we can calculate. X is how much? X is, this is 2a. Let us draw the diagram here, right? So this is 2a, this is theta. And if this is theta, so this is base or perpendicular. This is what? Yes, yes, Saad. So yeah, this is
X,
theta, this is, yeah, x, and x would be what? Base or perpendicular?
perpendicular, sir.
Perpendicular, right? So you know that this is a known quantity. Theta we know, and the distance of this dipole we know. So can you tell me what relates hypotenuse with the perpendicular?
Cos theta.
Think again, think again. Yeah,
Sin
Aisha,
theta,
what
sin theta.
relates? Yeah, confirm. Lock कर दिया जाए.
Yeah. Ji.
Yes. Okay. Okay. Yeah. So Aisha, that would be sine theta, right? We are
Yes.
correct, or
Yeah.
yeah. So sine theta is, let's say this we have represented as x by, let's say, 2a. So x would be 2a sine theta, right? X is 2a sine theta. So now we know that x is 2a sine theta and f is how much? QE. Right. So this is 2aq e and sine theta. Okay, so Mariam, you tell me what is 2aq?
P vector.
Yes. So P magnitude, right? So P E sine theta. Okay, so this is the top. And we know that what is this magnitude? So this is the magnitude of a cross product, right? Right, guys? So the
Yes.
torque would be, yeah, so the torque would be P cross T. Okay,
Sir,
so
how
yes,
to a
yes,
how
how?
to AQ be?
Yeah. So we know that the dipole moment is defined as the separation into the charge, right? So separation is how much? Separation is 2a. So we remember the dipole, right? So the separation is 2a and this is charge magnitude is q. So 2aq would be the magnitude of this dipole moment. So now you remember.
Yes, sir.
Yeah, so yeah, when we were discussing this dipole moment, so then we discussed the magnitude of this type, right? Okay, so yeah, you guys please note down this part, right? Any doubt in this part?
No, sir.
Okay, so please note down this part. So whenever you guys have finished noting, please tell me then I will do a question and then we will understand about the special cases of this talk.
Done.
Done. Yeah, Aisha and Saad, done.
Yes, sir. Done.
Okay,
Yes, sir.
so Saad, done. Okay. So let us do one question based on this problem. Right. Let's say we have, let's say some electric field, which is, let me get the value of the electric field. Yeah. So
Why
yes,
product?
yes, Aisha, do you have any question?
Yes, sir. Why is it a cross product?
Yeah, because you see that what is the magnitude of P sine theta, right? Whenever you have, so we discuss about this cross product, right? So the magnitude of a cross product is AB sine theta. Okay. If this would have been a cos theta, right? If somehow this would have been a cos theta, so then it would have been a dot product. Okay.
Okay. Yes, sir.
Yeah. So there was sine theta. We took this perpendicular distance, right? And this perpendicular distance gave us, so this x gave us this sine theta part, right? So this sine theta is dependent upon this angle. right? So which means that it would be either cos theta or sine, or it would be a dot product or cross product. So in cross product, we get this sine theta, right? So that is why. And we also know that this is a torque, so this is a vector quantity, right? So then again, it shows that it should be a cross product. Okay.
Yes, sir.
Yeah, because we are multiplying some moment and electric field, and there is a sine theta sitting beside that. So you are multiplying two vectors and you are getting the magnitude of two vectors and then the sine theta. So that happens in the cross product. So that is why this cross product. Yeah. So what was the question? You have an electric dipole, right? In a uniform electric field of okay, of E equals to, let's say, 15 Newton per coulomb, right? Let me write the magnitude of, right? So we have to find the torque on electric dipole. Shown in the figure, right? You have this electric field which is 15 Newton per coulomb, and this dipole is placed. So let's say that it is placed at an angle of 30 degree, and this Q is minus 4 microcoulomb. 4 microcoulomb. And what do you also need? So this distance is 3 millimeters. Okay. So you have all the information, you guys calculate. So find out what is tau. Please, you guys find out and then tell me the answer. Okay. Yes, guys, please find out and tell me the answer.
Yes, sir.
We know that what is torque, right? Magnitude of torque is how much, guys? Yes, Saad. Magnitude of torque is how much? Saad. Hello, Saad.
Oh,
Yeah.
yes, once.
So magnitude of torque is how much?
3 mm into 4 microcoulomb.
No. Just tell me the formula that we just write. Yeah, Aisha. What did we derive? What was the formula for the torque on electric dipole?
Torque is equals to PE.
Yeah, PE, and then you have sine theta, right?
Yes.
Okay, so yeah, this is you need to calculate Saad. So you calculate P, E is given, and sine theta is also given. So you guys calculate this, okay, and tell me the answer. Yeah, did anybody get the answer? Yes, Mariam, Aisha, and Saad. Did you guys get the answer?
1 minute, sir.
45. Okay. 45. 45 Newton meter, right? So Mariam answer is 45 Newton meter, right? Yeah. So Aisha, did you get 45 Newton meter?
Sir, 1 minute.
Yes?
1 minute, sir.
Okay. 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 Yes, Saad sir, how much did you get? What did you get, Saad?
I got wrong, sir.
Oh, yeah. So, Saad, your exam is over or it's still happening?
No, sir, it's over.
It's over. Good. Okay. So now you can relax a bit, right?
Yeah.
Yeah. And the next Saturday is the last one, right? Sunday.
No, sir, 24th June. So
24th
one
in
more
June.
week.
Oh,
Yeah.
no, I'm talking about that Demon Slayer.
What, sir?
Demon Slayer, Demon Slayer. So,
Oh,
yeah, Sunday, next Sunday, next Sunday is the last one. And that would be
yeah.
70-minute episode. Okay, yeah, rest of the guys, did you guys get the answer? Yes, Aisha, what did you
Mm.
get? Okay, let us calculate here. Okay. Yeah, so P would be the separation, which is 3 mm, and 3 mm is how much? 10 to the power minus 3, and into D. Okay, so into Q. Q is 4 and microcoulomb, so 10 to the power minus 6. Right, so this is 12 into this is 9. This is P, right? This is P, and how much is so E is 15 Newton per coulomb, right? And this is how much? So this is charge, and this is meter, coulomb meter, right? And we have this sine 30. So sine 30 is half, right? So our torque would be P, which is 12 into 10 to the power minus 9, and 15, and this is half. So this is 6. So this is 90 into 10 to the power minus 9. So I'm getting 9 into 10 to the power minus 8, right? Newton meter. So yeah, Aisha, what did you get? And Mayim, you please check your answer. Right. Yes, guys. So did you guys, so are you getting the same answer, Aisha?
Yes, sir.
Yeah. And Saad, so what did you get?
Mm,
Yes.
so
The same answer or different one?
different.
Different. Okay. So please check your answer, Saad. Right.
Yeah, I got my mistake.
Okay. 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 So now let us talk about the conditions for different conditions for the torque on electric drive. Right. So special cases for torque on electric dipole. Right. So first condition is that when the torque will be maximum. Right. I have this electric field. Right. And I have this dipole, which is making an angle theta. So this is minus Q, this is Q, right? And this is the electric field. So we know that the magnitude of torque is PE sine theta. Right, this electric field is constant, this P is constant. So this torque is dependent upon this sine theta. So when is the sine theta maximum, guys? Yes. So when is the sine theta maximum, guys? What is the maximum value of sine theta? Sine goes from,
180.
yeah. What did you say, Maria? -1 to 1. Yeah, sine goes from, right. So this is 1 and this is -1. So sine goes from -1 to 1, right? Right, guys. Am I correct?
Yes, sir.
Okay. So what would be the maximum value of sine?
90.
Sine. Maximum value of
180.
sine. 1, right? Yeah. So your answer is correct, Aisha, that if I ask about this angle, right? So yes, I was coming to this point, theta. Yeah, so the maximum value of sine theta is 1. And what is the angle for which this, so this angle represents, minimum angle represents theta equals to, so if sine theta is 1, so theta is 90 degree, as Aisha said, right? So then torque would be simply PE, right? So this is how we place this dipole to have the maximum torque, maximum rotational force, right? So for this theta should be 90 degree. Understood, guys? Any doubt in this?
No, sir.
Okay, yeah. So and then let me talk about this second case. And then you guys note down. Okay, so one would be the minimum, or this is also called the stable equilibrium. Equilibrium. Okay. So in this stable equilibrium, you have this electric field, right? And this dipole is making an angle. This is minus Q, this is Q, and this is the dipole moment. So what is the angle between the electric field and the dipole moment? Yes. What is the angle between the electric field and the dipole moment?
0.
Yeah. So the angle is 0. So PE sine 0. So this is 0, which means that it will not rotate, right? So this is called the stable equilibrium. If I put, so this is the electric field and I have placed the dipole like this, right? Remember that my negative is this side in the left hand side, my positive in the right hand side. So that the dipole moment is in the direction of the electric field. Did you guys understand that part?
Yes, sir.
Yeah. So for this, theta should be how much? 0 degree. Right. Okay. Now we have this. Okay. So you guys, please note down this part and then I will talk about this last case. Yeah. Any doubt in this part, guys?
No, sir.
Okay. So what is the meaning of this stable part? That if I change the position of this dipole, right? So it will come back to this point, right? So that is why it is called the stable equilibrium. Okay. And then the other case is this unstable equilibrium. Yeah, noted, guys.
Done, sir.
Yes, Saad and Mariam, done.
Yes.
Yeah.
Okay, so the next case is this unstable equilibrium. Okay, you have this uniform electric field, and the dipole is placed like this. So this is minus q and this is plus q. So what would be the direction of the dipole moment, Saad? Yeah, right, left, up or down? Yes, yes, Saad. What would be the direction of the dipole moment? You have this dipole, right? So what would be the direction of the dipole moment?
Left side, sir.
Yeah,
To left, positive.
to left. Yeah,
Minus.
to the left. Yes. Yes, yes, correct, correct. Minus q to positive q, right? So you can see that what is the angle between this dipole moment and this electric field? So angle between P and E is 180 degree, right? So your tau would be PE sine of 180 degree, and this 180 degree is also 0. So your tau is minimum, right? But this is the unstable equilibrium, because if you move this dipole at some angle, right, so it will not come back to its original position. So this is why it is called the unstable equilibrium, right? Just remember this diagram. So you have this diagram and you have this diagram. So let's say that you move this bead in here, right? So if you move this bead in here, it will come back to its initial position. So this is called the stable position. Understood, guys? And let's say that if you put the beads or some ring in here and you move this ring in here, so it will drop from here, it will not come back to this position. So this is the unstable equilibrium. Okay, understood, guys?
Yes, sir.
Yes, guys, understood?
Sir,
Yes,
sir, can you explain again?
this diagram.
Yes, sir.
Okay, so let's say you have this U-shaped something, right? And in this U-shaped, you have put some ring or something like a mass or something object, right? So let's say you move this mass here. You put this mass here. So due to gravity, it will come back to this point, right? It will go here and then oscillate and then come back to this point, right? So this
Yes.
position will be called the stable point because however you move this object, it will come back to its initial position. Understood?
Yes, sir.
And for this part, if you move this object to the right or left side, right? So if you move this to here, it will go down. It will not come back to its initial position, right? If you don't touch that, it will remain there. It will remain there. So that is why it is called equilibrium, right?
Yes.
But if you move this part, then it will not come back to this original position. So that is why it is called the unstable part. And stable comes from that if you move this object in here, it will oscillate and then come back to its original position. Right? Understood, Mariam?
Yes, sir.
Okay, so you guys note it down and then we will do one topic of this electric dipole and then we'll start this Gauss law. Right. So I hope that in next two classes, this first chapter will be finished. Okay. Did you guys note down this part?
Yes, I done.
Yeah. So the next, this is just like a question we will. So this is a question that comment. Oh, comment on the motion of an electric dipole in the presence of a non-uniform. Right. So whatever we were doing up to now, that was in the uniform electric field. But in this question, this is telling about this non-uniform electric field. So let's say at this point, electric field is E1, right? So let's say this is positive Q, and at this point, minus Q. Let's say this is electric field, right? The separation is different, and at this point, you have this electric field which is E2, right? So you see that the electric field is different. Okay. So this force would be one force which is Q E1. This is, let's say, let me write it here. So this is F1, which is QE1, right? And at this point, the force would be in which direction? In the left direction, right, guys? So this will be, yeah. So this would be F2, which is minus of QE2. So you see that you have two forces. One force is different, F1, and the other force is different. So if this force is larger, so the dipole will move in which direction?
Sorry.
So let's say you have a dipole placed like this, and this part is pulling it in this direction, and this part is pulling it in this direction. And let's say that this part is pulling, this has more force, and this has lesser force. So this will move in this direction, right? Right, guys?
Yes, sir.
So this will have a translation motion, right? So net F net is not 0. So it will have a translation motion. And again, you have a different force, different couple. So this will have a torque, right? Torque also. Right, guys? So tau net is also not 0. So this will have a rotational motion also. So can you guys give me one example where you have this rotational motion as well as this translation motion? Can you guys give me one example? Yeah. What is the example of a motion where you have this translation and rotation motion? Yes, guys. Any example that is coming into your mind? Forgotten, guys. So let's say you have some let's say you have a cylinder, right? And you are just kicking that cylinder, right? So it will rotate and then move further. So it is rotating, which means that it has a rotational motion, and then it is moving further, which means that it will have a translation motion, right? Understood, guys?
Yes, sir.
Yeah, so you have seen the example of an inclined plane. And let's say an inclined plane, you put some sphere. So a sphere, what does sphere do? It will rotate on its axis and then it will go down. So that is called the rolling motion, right? So in rolling motion, you have this rotation motion and the translation motion. So this dipole, what this dipole will do is that it will roll and then move like this, right? So let's say this will go like this, right? This will go like this. Understood, guys? Whichever force is bigger, so let's say this F1 force is larger, so this will go like this. Understood, guys?
Yes, sir.
Yeah. Any doubt in this question, guys? Yes. Any doubt in this question, guys?
No, sir.
Okay, so please note down this question. You have to write all those part that I have just told you. You have to write that if the forces are different, then it will have a translation motion, and then if it has also some couple, so it will experience some force, rotational force. So then it will also have a rotational motion, right? So this dipole will have a translation motion as well as a rotation motion. Okay, so if you guys have noted down, please tell me, then I will start the new topic.
Done, sir.
Done. Yeah, Saad and Mariam, done.
Yes.
Yes, sir.
Okay. So the next topic would be electric flux, but let me recap whatever. Correct? Yeah. Why this is not erasing this part? Okay. This is absurd. Okay, so you have what have we done so far? And Saad and Mariam, I will take a backup class when all the other people join, right? So when all the other people join, then Simultaneously, I will take some backup classes where I will repeat what I have done so far, right? So in the first part, we studied about this definition of the charges, right? And then we learned about this features of charge. And then in the third part, we learned about this basic properties of charge. And in this, so in the feature part, we learned about that whether this is scalar, how do we represent the charge, what is the SI unit, what is the value, why this is neutral, and something like that, right? So in the feature of charge, we understood about that part. In the basic properties part, we learned about 4 properties. One was this quantization. The second was this additive nature. Third was this was what? Yes, Aisha. What was the
Conservation.
other? Yes, conservation. And the last,
Invariance function.
invariance. Good. Yeah, invariance. Right. And then we learned about this. So in the next, I will just keep revising whatever I have done so far, right? So that you guys can repeat those part or revise those part. So in the next part, we learned about this Coulomb force, right? And then we talked about this superposition principle. Of the force, right? Then we learned about this electric field, right? Then we learned about this superposition principle. Of electric field. And then we learned about this Coulomb force in vector form. Okay. And then we need to remember that whenever we calculate F12, so this is always R1 minus R2 divided by R1 minus R2 magnitude cube or square, Aisha. Yes.
Cube.
Yes, Aisha, what did you say? Yeah, Aisha, do you remember? Maybe you are not audible. Yes, Aisha, what did you say?
Cube.
Q, right. Yeah, and then we learned about this electric field lines, right? We learned about the 8 properties. And 10th in this 10th part, we learned about this electric dipole. And then we calculated the electric field of the electric dipole. Right, the axial and the equatorial. So axial was 2kq by 2kp by r cube. Equatorial was how much, Aisha?
Kp by r cube.
Yeah, minus kp by r. Right, good. So you have revised well. And then we learned about this force on charge particle in external electric field. Right, and then we learned about this torque on electric dipole. So you guys please revise those portion, right? So you guys need to keep revising that, then you guys can remember. Otherwise, you guys will forget. Whatever you have learned so far, you guys will forget. Okay, so yeah, I am here. Right. Oh, I was here. Why didn't I write? Okay. So the next topic is this electric flux. Mm, yeah, so what is this electric flux? Okay, so let's say you have a surface area, right? Let's say you have a surface. So let's say you have a square surface, and you guys tell me the surface is a vector or a scalar? Yeah. So surface is a scalar or a vector? Yes, Saad. Surface is a scalar or a vector?
Can you repeat again, sir?
Yeah, so this is a surface, right? This is a surface. So this surface is a scalar or a vector quantity. What kind of quantity is this? Scalar or a vector quantity?
Scalar, sir.
Yeah.
There is no direction, sir. So it's scalar, I guess.
Yeah. So the next question, so if I say it, let's say if I say it a vector quantity. So let's say that this is a vector quantity. The answer is that the surface is a vector quantity. So my next question would be, what is the direction of this surface? Yeah. So Aisha, what is the direction of this surface?
It could be any direction, right?
Yeah, so you have this square, so the surface would be perpendicular. The normal would be the direction of this sphere, right? So you have this surface S, and the direction of this S would be normal to this plane, right? So let's say that, right, I have a board, right? This is a surface. So the direction of the surface would be this normal. Understood, guys? Can you guys see this? So I have this surface, right? And the direction of the surface would be this normal. Okay, guys?
Yes, sir.
Understood?
Yes, sir.
Okay. So this is the direction of the surface, right? So electric flux is, yeah. So let's say I have this surface, right? And the direction of the surface is this normal. Okay. So electric flux is defined as this has some surface area, right? So the total electric field lines passing through this surface. Okay. So this is represented by this phi, and this is EA. Okay. This is electric field and this is the area. Right. So in dot representation, we represent it as E vector dot A vector. Okay. Understood, guys? So let's say that my surface is bent like this. So let's say my surface is this. So this is my normal vector, right? And the electric fields are moving in this direction. Okay. So these are making some angle theta with this normal. Okay. Understood, guys? So my flux would be EA cos theta. Understood, guys? Any doubt in this?
Yes, sir.
Yeah. So for this case, you guys can see that for this case, what is the angle between the surface and the electric field? What is the angle?
0.
0, correct. So for this case, the electric flux would be EA only, right? So the definition of electric flux is total incoming or outgoing electric field lines through a surface, right? And this is represented by E dot A, which is E A cos theta. Understood, guys?
Yes, sir.
Yeah. So you guys, please note down this part, and we will do a couple of questions based on this. Okay. Yeah, so we are doing this electric flux, and then we will do this Gauss law. So Gauss law is the last topic. Then this chapter will be over. Okay. And you don't have electric field due to line charge and electric field. Yeah, so you don't have this electric field due to hollow sphere, electric field due to this spherical, not the hollow sphere, but full sphere, and then the cylinder. So cylinder, sphere, and hollow sphere. This is not in the syllabus, guys. In the CBS syllabus. Okay. So I will skip that. Yeah. Did any of your teacher do this electric field due to hollow sphere and cylinder from the Gauss law?
Yes, sir.
They did in your class,
Yes, sir.
but
Applications
that
of
is not.
Gaussian.
Yeah, in the application of Gauss law, did they calculated this electric field due to hollow sphere, cylinder, and this sphere?
Yes,
Range of charge.
Okay, they calculate, but that is not in your syllabus, so I will skip that. Okay,
Yes.
yeah, because then you need to know about this integral, triple integral when you want to calculate the electric field inside the sphere. Hollow sphere is easy because you don't have electric charge inside the hollow sphere, but a sphere you need to know about this integral term, right? So yeah, did you guys note down this part?
no, electric flux is
Yes.
scalar.
Yes.
Is electric flux scalar?
Yeah, electric flux is.
Scalar.
Yeah, I couldn't. So your voice is breaking, Aisha. What did you say? Yes. Uh, yeah. Yes, of
So,
course. Yes, of course, electric flux is scalar because you have a dot product, right? So it is a scalar quantity. Yeah, of course, electric flux is a scalar quantity. Yes. So yeah, this is what you are asking, Aisha. Yes, sir. Yeah, so if you're asking that whether electric flux is a scalar quantity, so yes, it is. Okay, guys, note it down. Saad and Mariam, noted.
Yes, sir.
Okay, so let us do some question.
Sir, but then
So,
electric has magnitude and direction both, right?
flux.
Yes.
So it will not have a direction, right? It will not have a direction because it is a. So we count only the number of lines. Number of lines coming or passing through the surface. We don't,
Okay.
yeah. So we are counting the number of lines passing through that surface, right? We don't bother about this direction. Okay.
Yes, sir.
Yeah. So the direction is only important when we calculate the area. So it is only the dot product of these electric field lines and the area vector. So then it becomes then it becomes scalar, right? If it would have been some cross product, right? E cross A, then it would have been a vector, right? We are only counting the number of lines passing through an area. Okay.
Yes, sir.
Yeah. So let us do some question based topics. So let me see some questions. Yeah. So E is 10 Newton per coulomb, right? And area is 5 meters square in XY plane, right? So and electric field lines are inclined at an angle of 30 degree, right, with the plane of the area, right? So then find electric flux. Let me draw the diagram. Let's say this is some plane, XY plane, right? So what would be the direction of the XY plane? Let me draw it like this. So let's say that you have this XY plane. Right. This is some XY plane. And what would be the direction of the area vector?
Towards the normal to the.
Yeah, normal to this plane. So this is the direction of the this area vector. And the electric field lines are in this way. So they are making 60-degree angle. Okay, this is the electric field, which is 10 Newton per coulomb. So you guys calculate what is flux.
Sir?
30.
Yes. Oh, 30. Yeah. 30 degree. So you guys calculate the electric flux. Yes. What did you get, guys? Positive, negative, 25, or 0. So you have 3 answers, Mariam. How could that be?
No,
So
sir.
yeah,
In that
okay,
I meant
25.
only 25.
Oh, 25. Yeah. So 25. Okay. Aisha, 250 or 25? This is 10. Yes, so Aisha, 25 or 250? How much did you get? So this is cos 30, guys. Right. Not sin 30. Cos 30. Okay.
Sir,
Yes. Yes.
sir, what is cos 30?
No. Cos 30 is root 3 by 2. So cos is decreasing, right? Cos goes from 1 to 0. Sine goes from 0 to 1. Right. So sine goes from 0 to 1, cos goes from this 1 to 0. Right. This is so cos 30 is root 3 by 2. Yeah. So what would be the answer, Aisha and Saad? This is 10, this is 5, and this is root 3 by 2. So 25 root 3. And what would be the, so Newton meter square per coulomb, right? This is the flux. Understood, guys?
Yes, sir.
Yeah. And okay, so Saad, what did you get?
I got correct, sir.
Oh, good, good. Yeah, so then let us calculate this question. The electric field is 3I plus 4J plus 7K and Newton per Coulomb, right? And the area is 2I plus 4J plus 3K meter square, right? So find flux, electric flux. So we are talking about electric flux. Then you have some magnetic flux. Yeah, you guys find that and tell me. Okay, what did I? So, yeah. Okay. Okay, guys. So we have one mistake, right? What is the mistake? Can you guys tell me what is the mistake in this question? Yes. Can anybody tell me what is the mistake in this question? Yes, guys. So can you tell me what is this angle? Angle 30 with the plane of the area. So this is the plane, right?
Yes, sir.
This is the plane. Okay. And this electric field is making 30-degree with this plane. So this is the angle it is making. right? With this plane. Okay. So then with the normal, what would be the angle? We have to calculate the angle with the normal. So this would be 60. So Mariam answer was right. So this would be half, right? So this would be cos of 60. So then this is, so we have to be careful in this kind of question, right? So this is, yeah, Saad. So we are wrong. Yes. So we have to carefully look in this question. The angle that it makes with the plane, not the normal of the area vector. So it is making an angle with this plane. So this is a plane and the angle it is making is this 30 degree. So with the normal, it will make 60-degree angle. Understood, guys? Yes, Aisha, Saad and Mariam. Understood?
Yes.
Okay, so please correct your answer, guys. Yes, Aisha and Mariam. Understood?
Yes, sir.
Okay, so please correct your answer and then do this question. In the next class, I will start this Gauss law and the application of Gauss law. And yes, just like the everyday class, we have this class assessment. So please be here for the after class assessment, right? So today the topic would be just we learned the talk on electric dipole. So yeah, and I have also found the result of those previous class assessment. So what I will do is that I will discuss all those questions in the class in the next time, because I wanted to first complete these syllabus. So that's why I didn't talk about that. But in the next class, I will talk about the I will talk about the assessment questions. Okay, guys.
Yes, sir.
So some question you were not able to do, so I will just talk about those. Yeah, what did you get, guys? What is the answer for this question? Yes. Anybody? What is the answer? Yes. No one got the answer. 6 people. Okay. Yeah. So Sana has come. She will take the class assessment. Yeah. Aisha, Mariam, and Saad. What did you get? This is simple, guys. Right? What is phi? Because these are given in the vector form. Right, so E dot A would be simply 3I plus 4J plus 7K and dot 2I plus 4J plus 3K. So what is I dot I, Saad, what is I dot I?
Dot across cos.
I dot I, cos? Yeah, cos, yeah, so that is cos. So what is I dot I? What is the angle between I and I? You guys have
0.
forgot. Yeah, so I dot I would be how much? Magnitude of I. So magnitude of I, and cos of 0. So I is 1, this is 1, this is 1. So I dot I is 1, right? I have talked about this dot product, right? Aisha, did I talk about this dot product? So in the vector part, I talked about these, right?
Yes, sir.
Yeah, so I dot I would be 1, I dot j would be 0, I dot k would be 0. So only 3i and 2i will survive. So this is 6 plus 4 into 4, 16, and 7 into 3, so 21. So this is 22 and 21, 43. And Newton meter square per kilo. Right, guys? So this would be the answer. Okay.
Yes, sir.
So yeah, did you forget about these dot product, Saad and Saad? Do you remember the dot product?
Can you repeat again, sir?
Yeah. So do you remember this dot product? Yeah. What is this? Is my voice? Oh, this is very irritating. Yeah. So yeah.
What?
So you remember this dot product, right?
Which product,
I'm
sir?
asking that dot product, scalar product. This dot product.
Yeah. Yes,
It,
yes.
yeah. Yeah. So yeah, I dot I, you know, that would be 1. I dot j would be 0. Yeah. So any doubt in this question?
Yeah.
Any doubt in this question, guys? Any doubt?
No.
Okay. Yeah. So you guys please log into. So this is what I wanted to do in this class. So the next topic would be this Gauss law. So I will talk about Gauss law in the next class, right? Before I do that, you guys just calculate what would be the. So you guys just note down this question. You have this electric field, which is 3i plus 4j plus 2k, and area is 5 meters square in the XY plane. Okay, so find flux. This simple question as your homework. Okay,
Yes, sir.
did you? Yeah, so this is a very simple question as your homework. You guys please try that and send me the homework. Okay. So you guys log into your app and the test would be active. So please take the test and yeah, Sana would be just invigilating those tests. So yeah, Sana, over to you. Bye guys. Allah Hafiz.
Thank you, sir.
Yeah, bye guys.